So, good morning everyone. Welcome to the session on center of gravity. So, in this strength of material series, we have already discussed four topics, so which is available in the playlist. So, if anyone has not yet watched it, you can go and watch it in the strength of material series, right? So, this is the fifth topic, that is center of gravity, right? So today we are going to discuss how to find center of gravity for a different shapes, right? Before going into it, very important information, that is India's largest weekly competition, that is exclusively for GATE, which is going to be happen, that is today on June 27th, exactly at 11 a.m. That is 1 hour from now. Okay, so what is the special about this Unacademy combat test? Initially 60 minutes will be provided for a preparation, and typical kind of GATE questions will be asked in a live, which was picked by the India's best educators. So you have to answer those questions in live itself, right? So it's a live competition, right? So once you answer the question, all the leaderboard or all your marks will be provided in a live, that is leaderboard will be updated on a live. Okay, so which means you are competing with the India's best minds and your score will be updated in live. So you may know that what is your advantage, what is your strength and weakness, and where you are standing while competing across the country. And most important thing is a detailed video solutions, that is once the session is over, a detailed solutions for all the questions which is asked in the question paper, everything will be provided. So you may know or you can come to know that what are all the mistakes that you have done with the perfect solution also. So that is very important. Before going for an examination, you must know where you are standing. This is one of the largest tests which is very interesting, and more important is it's typically a GATE kind of question. Okay, and if you need to attempt this Unacademy Compact completely free, you need to use the code PSK20, where while opening the Unacademy app, the Unacademy Compact will be popped up, where if you use the code PSK20, you can freely attempt this Unacademy Compact test. And not only that, if you get a rank from 1 to 3, you will get a completely 100% free complimentary 1-year subscription. Okay, so that is 1-year subscription is completely free for you if you get rank 1 to 3. If you get a rank 4 to 7, 75% offer will be provided for a subscription. And from rank 11 to 50, you'll be provided with 50% of subscription, that is offer for a subscription. And from rank 51 to 100, you will get 25% offer for a plus subscription. So this is an additional benefit if you're going to attempt the Unacademy Compact, right? Great. Right. So next thing is, this is GATE 2021 top rankers who opted Unacademy as their learning platform, and they have achieved to this height, that is under mechanical category, production and engineering science category, and this is for your information. Now there are two types of subscriptions. One is plus, another one is a iconic subscription. In a plus subscription, you'll be having the access to all live classes that is provided in the platform where you are subscribing to the category, and crash courses will be there, and every week you'll have a weekly test to review what you have learned it, and every 4 sessions a doubt clearing session where your doubts will be clarified then and there, and the sessions will be in both English and Hindi with RIB and provider. So this is for plus subscription. If you are going for an iconic subscription, you'll get all these things. Additionally, you will also get a perfect study planner which is handmade, that is which is customized specifically for yourself based on your previous performance, and personalized coach will be there to make a perfect preparation strategy, and doubt clearing instructors will be provided to clarify your doubts specifically for yourself, and preparatory study materials will be there to prepare, and you can download the preparatory materials and you can use it for your preparation purposes, and study booster sessions to guide you how to attempt the examinations and how to handle the questions, whether it is easy or tougher, with the regular workshops. And personalized test analysis will be there to provide a micro level analysis about your performance, so that you can easily find out your weaker areas and improvise it. There are two types of subscriptions. One is Plus and Iconic. Now, why it is more important now? Here, from the July 1, the price is going to be high for GATE and ESE category. So if you are planning to subscribe it, do it now itself. And if you need to go, if you use the code PSK20, you will get a maximum discount while subscription. And moreover, you will also get that efficient revision via digital notes. That's the important thing which is coming soon, right? And while going for a subscription, for many types of subscriptions that is available in the space where referral code, use the code PSK20, right? So you will get immediate discount where it is visible here. You can see, right? The discount is visible, right? Which is, this code is applicable for all type of subscriptions, right? Next is, there are two batch courses that was kickstarted on 23rd June. The advantage of this batch courses, you don't need to search an individual topic or individual courses. So in this batch course, from the starting, that is, your complete syllabus will be covered, and every day you have to spend 2 to 3 hours of time to watch the classes, and the batch course itself planned perfectly that daily you have to spend only this much of time. So if a person who are planning to go for a 2022 and 2023, this batch courses are very interesting and very useful one, and it's already pre-planned, so it's easy for you to follow it. And another advantage is, the course will be handled from fundamentals, numericals will be handled, MCQs will be there, previous year questions will be discussed, so everything will be there. Okay, so you can use the code PSK20 to get into this batch course, right? Okay, so now we are moving into our topic, that is center of gravity. Okay, so before going into it, most of them will have a doubt that centroid, center of gravity, what is the difference between centroid and center of gravity, right? Most of them will have a doubt in this, right? So in a simple manner, and a plane figures, that is a two-dimensional, simply we can refer it as two-dimensional, right? If it is a two-dimensional, then we can call it as a centroid. If it is a three-dimensional, we should use center of gravity alone, but if it is a two-dimensional, we can also use center of gravity, but the perfect terminology is central, right? Okay, so let's clear why two-dimensional and what is a two-dimensional. Where in a plane figures like circles, polygons, like rectangle, hexagon, pentagon, right? Like polygons, which has only areas and there is no masses, right? Only areas and there is no masses, and that's why I have simply written as two-dimensional. That means it has only a lamina or layer or a surface, right? It's not a solid object, it's just a layer, a thin layer. Okay, so that's what a two-dimensional. So when there is only areas and no masses, we call it as a two-dimensional, and center of that area is known as centroid. Exact center of the area is known as centroid. Sometimes we may also represent as center of gravity. Okay, right? On the other hand, if it is a three-dimensional, that means if it has a masses, a solid object, then center of that solid object we will represent as center of gravity, and here we should not use centroid. Only center of gravity has to be represented, right? So two-dimensional centroid, three-dimensional center of gravity. That's it. A simple difference here. Okay, now how to find this centroid or a center of gravity? Basically, there are three kinds of methods which is used to find the center of gravity or a center. Three methods are geometrical consideration method, moment method, and graphical method. So now we are going to use the one of a simple method, right? Now we are going to use one of the very simple method to identify the center of gravity. Okay, right? So let's go by the geometrical consideration method. We are completely going to use only geometrical consideration method because that is the easy one to calculate, right? Okay. Now, before going into the numericals, I would say few basic shapes and what is the center of gravity of the basic shapes, right? I will explain it. Okay. First of all, center of gravity of a uniform rod. If it is a uniform rod, that means it's a circle, right? That means it's a circle. So circle means exactly at the center point you will have a center of gravity. That means the center of the circle is the center of gravity. So it's been very simple. We don't need to go much into it, right? Simple one. And center of gravity of a rectangle or parallelogram is at the point where the diagonals meet each other. Also, we can also find by middle point of length of breadth and rectangle. So what is the meaning? If it is a parallelogram or a rectangle, if you join the diagonals, okay, if you join the diagonals and the meeting point of this diagonal joining, the meeting point of diagonal joining is the CG. Simply we can do just joining the diagonals, we can find the CG. Or else the another method is find the midpoint of length. So the length DC, the midpoint is here, and draw a vertical line, that is perpendicular line here. Okay, same way find the midpoint of this length CB here, right? Now draw a horizontal line. So these two lines meet at a point and that is the CG. Simple, right? So two different methods for a parallelogram and rectangle, right? Good. So coming to the triangle. Now how to find the center of gravity for a triangle? Where three medians meet is the CG of a triangle. So median from CF, second median and third median, if you draw it, three medians will meet at a point and that is the CG. Okay, this is for a triangle, right? Now trapezium, how to find for a trapezium? If you take a trapezium where smaller breadth is A and larger breadth is mentioned as B and height is mentioned as H, where the CG lies at this point, because if you draw a two axes, right, X and Y, for example, if we draw two axes X and Y, about Y axis, that is about vertical axis, this trapezium is symmetrical. Okay, the trapezium is symmetrical, so no need to worry. The center of gravity lies exactly on the vertical axis, right? It lies on the vertical axis, but we don't know the horizontal position. Okay, but it lies on the vertical axis, right? Because it is symmetry. Now about x-axis, horizontal axis, it is not symmetrical, so that's why you have to find the position. So how to find this position? From the larger end, this is the larger end, this is the smaller end. Okay, from the larger end, the distance to the CG is h by 3 b plus 2a b plus a. You can see here. Okay, b plus 2a b plus a, right? So it should be measured from the larger end. Keep this point in mind. We should measure from the larger end, right? Okay, right. Next thing is for a semicircle. If you take up the semicircle, similarly, horizontal and vertical axis, that is x and y axis. About y axis, this semicircle is symmetrical on both sides. Okay, you can see about y axis it is symmetrical on both sides. So the center of gravity lies exactly on the G, right? CG exactly lies on the G, right? Okay, so which means it lies exactly on the G, which means here you don't need to worry about the y-axis. You should go about only x-axis. So about x-axis it is not symmetrical, so you have to find the position of x-axis from the baseline. Remember, it should be taken from the baseline. The height is 4r by pi, 4r by pi, okay, where r represents the radius here. Clear? Right? Good. Next, for a circular sector, right? Remember, for a circular sector, radius, that is slant radius, or radius we will call it as, and alpha, the angle is alpha. From the midpoint, the distance to the CG is 2 by 3 r sin alpha by alpha, where about vertical axis it is symmetrical, so CG lies on the vertical axis, right? Coming to hemisphere, from the bottom the height is 3r by 8. From the bottom height is 3r by 8. And for a circular cone, again the vertical height, you can see it's not a slant height, it's a vertical height h. And now from the bottom the distance is h by 4. And you can see for a sphere, from the midpoint height is 3 by 4, 2r minus h by 3r minus h. And h means, you can see the distance where I have already mentioned it, right? Right. And more important, for a cube, it's simple that exactly at the center point of cube, L by 2 from all three sides. If you do L by 2 on each face and joint it, you will get the center of gravity for a cube. And for a sphere, the center point, as like circle, the center point of sphere is the CG. Got it? So these are the few simple shapes where you needed to identify the center of gravity. Now we will do few numericals here. Okay, right? Right. Now, in the first question, we are discussing about T section. Okay, it is a typical T section. So in this T section, A, B, C, D, E, F, G and H. So the first work, what I'm going to do, is I'm splitting this T section into two simple rectangles. Okay, rectangle 1 and rectangle 2. So rectangle 1 means ABCH. Okay, rectangle 1 means ABCH. Rectangle 2 means EFGD. Right, this is the rectangle 2. So the first step is to split the shapes into a simple one. What are all these simple shapes? Rectangle, square, triangle, trapezium, circle. These are simple shapes. So we are splitting into a simple shapes. That's the first step. Second step is find whether it is symmetry or not. Let me write it down. Split into simple shapes. Okay, split into simple shapes. Second thing, draw X and Y axis. So you have to draw the X and Y axes. So here Y axis, which is already there, this is Y axis, and X axis, let's imagine there is an X axis. There is an X axis, right? So next step is find symmetry about X and Y axis, right? Find symmetry about X and Y axis, whether the component is symmetrical about X and Y axis. You have to find, right? So about Y axis, if you draw the Y axis on left side and right side, it's completely symmetrical. Okay, so on left side and right side it's completely symmetrical, so that you don't need to worry about it. The CG exactly lies on the YY axis. Okay, CG lies on the YY axis. But if you draw the X axis, if you draw the X axis and if you draw the x-axis and find out whether it is symmetry, no, it's not symmetry. So you have to find this position of x-axis. That's it, right? So you have to find the position of x-axis. That's what our aim here, right? So for that, what we have to do, next thing is mark the origin. Next thing is mark the origin. Right. So what is origin here? Why I need to mark this origin? Right. So you can see in this component, in this T section, bottom left corner, right? Remember, bottom left corner, even I can write it, bottom left corner. Always mark bottom left corner. Why I am selecting bottom left corner? Because if you take a graph, if you're having a component at first compartment, second, third and fourth quadrant, for example, for the first angle or first compartment, the origin is bottom left compartment, bottom left corner. You can see for the first angle projection or first quadrant, the bottom left corner is the origin. For a second quadrant, bottom right is the origin. For a third, top right, and for a fourth, top left. Now, why I am selecting bottom left corner means simply it's a first angle projection or a first quadrant. Why? The x values and y values are positive. The x and y values can be represented in positives. Then only you will draw it in the first quadrant. If x is negative, you should go for a second quadrant. If both x and y are negative, you will go for a third quadrant. Right. Similarly, if I draw in the first quadrant, while calculating, I don't want to use that negative sign to represent the position. So, obviously, there may silly mistakes happen if we are using those negative signs while calculating. Okay, yes, it is possible. A human error is possible. So, to avoid those unwanted errors, I am preferring the bottom left corner, that is first quadrant. You can also select other 3 quadrants and solve it. There is nothing wrong in it, and you will get the same answer only. But in order to avoid the silly mistakes, to avoid the unwanted humor errors, I am using the first quadrant because it's the simple one, right? It's the simple one to solve it. Okay, right. So bottom left corner of this total section, if you draw the total section, the outermost line, if you have to draw a rectangle, right? You have to cover complete section with the rectangle, and for that rectangle, bottom left corner, right? That is the next point, right? Next is center of gravity for individual shapes. Find center of gravity for individual shapes, right? So what is the individual shapes? Here we are having 2 rectangles, okay? So you may have a semicircle, circle, hemisphere, whatever, based on the question. Here we are having 2 rectangles, so we have to find the center of gravity of that individual shape. So we are taking the rectangle 1, and what is the center of gravity of this rectangle 1 alone? How to find out? Either connect the diagonals, so you will get the center of gravity, or from the length draw a midline, from the breadth draw a midline. You can kind of find out, right? So based on these 2 methods, you can find the CG here. Now similarly for the rectangle 2, you can find the CG by connecting the diagonals or by length and breadth method. Okay, so any of these 2 methods you can find the CG. Now I'm saying that already the CG of this whole section lies on y-axis because it is symmetrical, right? Because it is symmetrical. So you can see the CG of both rectangles, it's exactly lies on the y-axis, right? It's exactly lies on the y-axis. So we don't need to worry about y-axis. Our only aim is to identify about x-axis. That's what our aim here. Okay, right? So for that, we have to find the position of this G individually. So y2 y. What is the y2, y1 and y2? They are representing that we are not worrying about y-axis because CG lies on y-axis. We have to find the position of x-axis. So in order to find the position of x-axis from the origin, right? We have drawn the origin point, right? From the origin, the vertical height of x-axis has to be found out. For that, from the origin, vertical distance of each rectangle. So from the origin, this vertical height represents y2. From the origin, vertical height of first rectangle represents the y1. Okay, so you have to find the y1 and y2. So how to find this y1 and y2? y2, that is simple. The total rectangle height is 150 minus 30, it's 120. 120 by 2, it's 60. Right? 120 by 2, it's 60. Right? Simple. Because half of the rectangle. Right? Similarly, y1 value from bottom up to this bottom layer, the height is 120. 120 plus, what is this small height? The total height is 30. It will be half, right, by breadth method. So 15. So 120 plus 15 is 135. So y1 value is 135 and y2 value is 60. 135 and 60 is the two values. So now next is CG for individuals, and next step, we have to find area, right? Area of individual shapes, and next is x1 x2 to xn and y1 y2 yn values, whatever it is necessary. Here this x1 x2 value is not required because y-axis is at its position. We have to find only y1 and y2, where we have find out y1 is 135 and y2 is 60. Right. So next step is find COG directly. Right. So we are going to find out. Right. So already from the first step, splitting into two simple shapes is done by splitting two rectangles, drawing the x and y axes. So x and y axis has been drawn. Find whether it is symmetrical about x and y axes. So yes, about y axis the component is symmetry, but about x axis it's not symmetry. So next is mark the origin. So the origin should be marked bottom left corner of the total shape, bottom left corner, and find the COG of individual shapes, and area of individual shapes has to be calculated, and we will do now. Area of rectangle ABCH, area of rectangle ABCH, that is equal to 100 into 30. Okay, so 100 into 30, that is equal to 3000 mm square. Right. So let's mention as A1. Now area of rectangle DEFG, where A2, that is second rectangle, where the dimension is 30 and 120. Okay, that is 3600 mm square. So we have find out two areas. Next is y1 value 135 mm, y2 value 60 mm, that we have already calculated, 135 and 60 mm. Next is x1 y1 value, everything is done. Next is directly center of gravity. For that, y bar value, we have to calculate the y bar value. That means a1 y1 plus a2 y2 divided by A1 plus A2, which is equal to A1 value is 3000 into Y1 value is 135 plus 3600, that is A2 value, into Y2 value is 60 mm, whole thing divided by A1 value is 3000, A2 value is 3600, A2 value is 3600, right? So the total value is 94.1 mm. Right, that is Y bar value is 94.1 mm. What is this Y bar value? Right, what is this Y bar value? Y bar means from the origin up to the distance. This distance is Y bar value. That is from the origin up to the x axis. From the origin vertical distance up to x axis is Y bar. That is 94.1 mm. So we have find out that 94.1 mm where x axis lies. So from the origin, mark a point 94.1 mm and draw a line where you can find the x axis and meeting point of this x and y axis. This meeting point is the CG. This meeting point is the CG. Got it? Done? And y bar is, we have find out. What about x bar? It's 0 because it lies on the y axis. Got it? Right? Right. So this is a interesting question, right? Now, this T section is symmetrical about one axis, right? That is y, and about other axis it's not symmetrical. Now we are going to discuss about it's symmetrical about x axis, but it's not symmetrical about y axis. We are going to discuss the next one where it's just another symmetrical about one axis, but here it is about x, right? So let's go step by step, right? So remember the steps which I have mentioned here. So hope surely it will help you to find out, right? Now we will go by step. Split the component into simple sections. That is the first step, right? Okay, right. Split the C section into simple rectangles, into a simple shapes. Here I am splitting into a simple rectangles, where rectangle 1, rectangle 2 and rectangle 3. Right, 1, 2, 3. First step. Second step is draw a x and y axis. So the x axis is already there. So I'm drawing only y axis. Y axis. So about x axis, find the symmetry. That's the third step, right? About x axis, the component is symmetry. That is, both sides it is symmetry about x-axis. But about y-y, no, it's not symmetry. So you have to find the position of y-y axis. Okay, you have to find the position of y-y axis. That's what you have to do. Right. For that, mark the origin, that is bottom left corner. Okay, bottom left corner is here. This is the origin. So bottom left corner of this total section, outermost point, you have to touch the outermost point of this total section. For bottom left corner, I have marked it as a origin. Next, COG, that is center of gravity of individual components. So the center of gravity, of individual components, it's not about vertical, because I already mentioned that the CG lies exactly on x-axis, right? But you have to find the position of y-y axis only, right? So for that, the position of y-y axis means you have to find the horizontal distance, right? So the CG of individual rectangle, rectangle 1, it was let's assume it was here. And okay. Sorry. Okay. Right. The CG is here. Okay. And CG of second rectangle is at this point. Okay. Now from here, next step is you have to find the area of individual rectangles. So area of rectangle 1, that is A1, which is equal to, its length and breadth is 50 mm into 15 mm. Okay, 50 mm into 15 mm. So which is equal to 750 mm square. Next, area of rectangle 2, second rectangle, that is A2, where the total height is 100 mm. The total height is 100 mm. You need only this part. Okay, you need only this part. So 100 minus 15, and there is another 50. So 100 minus 30. The remaining height is 70 mm. You will get the remaining height 70 mm. So 70 into the width is 15. The width is 50. So the answer is 1050 mm square. Next is area of rectangle 3, that is A3. The length is 50 and 15, which is similar kind of a rectangle one, because the total shape itself symmetrical about x axis, so obviously you will give the same value, rectangle 3. Right, so area of 3 rectangles have been calculated. Next is x1 value. So why x? Because in previous question we have calculated y, because the position of xx has to be calculated, so we calculated y bar value. Now position of yy is needed, we have to calculate x bar value. Right, so x1, that is for first rectangle from the origin, what is the distance, right? So this distance is x1. So we know that x1 is half of the total length. So half of the total length based on the length method. So the total length is 50 mm, half is 25 mm. Okay, so x1 is 25 mm. And what is the value of x2? This is x2 value. So the total width is 15 mm. Total width is 15 mm. So half of this width is 7.5. What is x3? So x1 and x3 values are same because rectangle 1 and 3 are symmetrical. So directly you can find out. Right. So next thing is you have to find the value of x bar. Okay. So that's the final step where you have to find the value of x bar. So x bar is a1 x1 plus a2 x2 divided by a1 plus a2. Sorry, there are 3 rectangles, so a3 x3 divided by a3. There are 3 rectangles, right? So what we have to do? Substitute the values. A1 is 750 mm square, x1 is 25 plus a 7.5 into 1050 plus 750 into 25 divided by total areas, that is 750 plus 1050 plus 750. Okay, right? So now if you calculate it, the answer is 17.8 mm. So what is this 17.8 mm? This is the x bar value. This is the x bar value. Now x bar means x bar value means from the origin this distance. From the origin this distance. This is called x bar and that is 17.8 mm. So now from the origin take 17.8 mm and draw a vertical axis, that is y axis, and meeting point of x bar and y bar means xx and y axis, where you can find, that is meeting point of x-x axis and y-y axis. This point is center of gravity. Got it? Done? Right. So that's how very easily we can calculate the center of gravity by geometrical consideration method. Right. So in the next class we will see how to find the moment of inertia with center of gravity. So if you know center of gravity, then moment of inertia is very easy. Right. So in the next class we will discuss it. Right. Thank you everyone.